Section 9.2, Series and Convergence. This video is the introduction to series. There is a second video to Section 9.2. Alright, let's get started. There are 3 bullets. Understand the definition of a convergent infinite series. Use properties of infinite geometric series. Use the nth term test for divergence. We are doing all 3 of these. Right? The first bullet is background information, and the second 2 bullets are specific tests. Specific tests. Some textbooks call this an geometric series test. Okay. Remember that this notation is denoting an infinite sequence, right, as n goes to infinity. Now, so if this is an infinite sequence, then this is the sum of each of those terms. Right? This is the sum of those terms. And this is what is called an infinite series. An infinite series is a sum of an infinite sequence. Okay? We're going to usually just call it series instead of calling it infinite series. Alright, the definition of a convergent and divergent series. Alright, so we have the infinite series notation here. The nth partial sum, right? So a partial sum means you're going to stop at a specific point, like say n equals 6 or something. So that's a 6th partial sum, okay? And so note this notation here. So it's S of n, and you're going to add up through a1 through an. So you're going to stop at a specific value. So Sn is only part of the series. It's not the entire series. Now, so this partial sum itself is a sequence, right? This is a sequence of sums. Okay, so this is kind of confusing because an infinite series is made up of a sequence of sums. Now, what we're looking at is what's happening to these sequence of sums. Remember, a sequence can converge. So these partial sums is a sequence, and we're going to have those converge. So Sn is a sequence of sums or partial sums, and it's going to converge to S, and S is the infinite series, right? So we're going to take Sn, S sub n, which is a partial sum, and we're going to let n go to infinity, and that could either converge to some value or it diverges. Okay. Yeah, I'm sorry, that was probably confusing. Let's look at some examples. So here, we have a convergent and so we're looking at convergent or divergent series. So let's look at this one. All right. So partial sums for this series. So S sub 1 is 1/2. S sub 2 is 1/2 plus 1/4, which makes 3/4. S sub 3, 1/2 plus 1/4 plus 1/8. So the first 3 terms become 7/8. 1/2, 1/4, 1/8, 1/16 becomes 15/16. Now, what I want you to notice is this pattern here: 1/2, 3/4, 7/8, 15/16. It turns out this pattern keeps going. So the next one will be, well, what's the pattern? The numerator is 1 less than the denominator. That's what I want you to notice. The numerator is 1 less than the denominator. So we make this formula, right? So S sub n is this formula, 2 to the n minus 1 over 2 to the n. Now we have a formula for this partial sum. We have this formula for this sequence of partial sums. So that means we could take that limit, right? So S of n equals this formula. That means we could take this limit as n goes to infinity of S of n equals this limit. I'll say that again. And here you have infinity over infinity, so we take L'Hopital's rule. And what is this? This is basically 1. So the limit is 1. So this series converges to 1. Okay, next example. All right. Oh, there it is. So the series converges to 1. In our second example, we have this weird combination. What I want you to notice in this series is that we have terms that cancel each other out. So this negative 1/2 and positive 1/2 cancel. And then the negative 1/3 and the 1/3 cancel. And you can imagine negative 1/4 is going to cancel the 1/4. Okay? So what happens is the 1 doesn't cancel and the last term doesn't cancel. Kind of. Alright. So we have 1 that cancels and the last term doesn't cancel. So it's basically this 1/n plus 1 term that's not canceling at the end. Okay, so if we have n terms, the one that doesn't cancel is the last term of 1 over n plus 1. So that means we can take this limit, right? This expression is equal to the limit of this. So we take that limit. What is the limit of 1 minus 1 over n plus 1? Well, 1 over n plus 1 as n goes to infinity goes to 0. So this limit approaches 1. So this series converges to 1. Alright, now look at this one. What is this doing? You're going to add an infinite number of 1s. So the Sn, the partial sum, is n. As n goes to infinity of this partial sum, right, which is, the formula is n, that's going to be going to infinity. So this diverges. So the series diverges, right? All this is going to, if you have an infinite number of 1s, it's still infinity. Alright. Alright, what you saw earlier, the one where they canceled, this was the canceling one. So this is the first term, A1. This is the second term. This is the third term. This is the fourth term. But, so the overlapping terms, or I don't know if that's correct, but the negative B2 and the positive B2 cancel, and then these two will cancel, and then these two will cancel. So you're left with the first term and the last term. This is called a telescoping series, right? What happens is all the middle gets canceled. Now, it doesn't have to be all the middle. It could just be like most of the middle gets canceled. So here's an example of telescoping series. Now, the bad news is it doesn't look like a telescoping series, right? It doesn't look like a telescoping series because it's one fraction. What we're going to do is take this. Remember, this is a sequence of terms. Each of these things that we add up together, they're a sequence of terms. So it's a sub n, and what we're going to do is rewrite this using partial fractions. We're going to rewrite this using partial fractions. So remember the technique for partial fractions. We take this fraction and rewrite it, factor the denominator. So we got 2m minus 1, 2m plus 1. And what we need to do is solve for the numerators. All right? So we're going to multiply through by the common denominator. When that happens, we get the 2 left over. And this term is a times the 2n plus 1. And this term is b times 2n minus 1. And then we're going to choose some values for n, right? So let n equals negative 1/2. If n equals negative 1/2, so if I plug it into here, that's going to be 2 times negative half, which is negative 1. The negative 1 plus 1, so the a gets wiped out when n equals negative 1/2. But over here, this becomes negative 1 minus 1, right? So 2, remember the a got wiped out, b times 2 times, oh, I'm sorry. 2b times negative 1 minus 1, which means that's going to be negative 2b, so b equals negative 1. Now, let's let n equals 1/2. We're going to wipe out this other one. We're going to wipe out the b, right? If I put 1/2 in here, 1/2 of 2 is 1, minus 1 is 0. So this b gets wiped out, but the a doesn't, right? Plug in the 1/2 there, you get 1 plus 1. So you get a equals 1, right? Because 1 plus 1 is 2. 2 equals 2a, so a equals 1. Take these values and substitute it in the rewrite, right? So a is positive 1, b is negative 1. So now we have this form. And this is a telescoping series, right? Here, Sn is going to be 1. If we plug in 1, that's going to be 1 over 2 minus 1, which is 1. And plug in 1 here, that's 2 plus 1 is 3, so that's 1 minus 1/3. So this term is when I plug in n equals 1. And then when I plug in n equals 2, I get this term. Alright, now what I want you to notice is that this part gets wiped out. So s, because these cancel out, negative 1/3, 1/3 cancels out. Negative 1/4, 1/5, and the next one gets canceled out. It gets all canceled up to this term. So Sn is 1 minus 1 over 2n plus 1. Now, so that means we can take the limit as n goes to infinity of this expression. All right, so this was the original. This is the telescoping version. We know by basic definition, the limit of Sn, the partial sums of this series, let n go to infinity. This was the expression, and there it is, right? So the limit of the partial sums is equal to the series. The limit of this partial sums is 1. So this series adds up to 1. Yeah, that was a mouthful. All right. so this series converges to 1. This series converges to 1. That's the end of part 1. All right, so in this video we discussed what a series is. A series is the sum of the terms of a sequence, right? And it is the limit of the partial sums as n goes to infinity. We talked about whether a series diverges or converges a little bit. I don't know if we did much with divergence, but there'll be more later on, okay? What a telescoping series is, right? That's when all the middle terms get wiped out. In the next video, we will discuss what a geometric series is and the 10th term test for divergence. Okay, so the first part was an introduction to series and talking about series divergence or convergence. Okay, so the most important part is part 2. Okay, that's the important one. Once you get this is kind of background information. So this will always be lurking in the background. This idea that a series diverges or converges. But you'll be basically learning the first 2 tests for series convergence or divergence. Right? The first 2 tests. There's like 10 of these tests that, yes, you have to memorize. All right, moving on. Okay, so yeah, no, moving on. This is the end of this video. Bye-bye.